Humans love extremes. Tallest buildings, longest bridges, and yes, even the biggest foods. We gather at state fairs to gawk at prize-winning pumpkins and watermelons. We watch in awe as competitive eaters tackle mountains of food. There's something deeply fascinating about things that defy normal proportions, especially when it comes to what we eat. Maybe it's the visual spectacle, the sheer audacity of scale, or perhaps it's the primal instinct, a celebration of abundance and bounty. Whatever the reason, giant foods capture our imagination, but how big can we actually go? What are the scientific limits to supersizing our food? Let's dig in. Some plants are genetically predisposed to gigantism. This means that certain species have the inherent genetic makeup that allows them to grow to extraordinary sizes under the right conditions. Scientists have been fascinated by this phenomenon for years, studying the genetic codes and cellular structures that contribute to such massive growth. Pumpkins are a prime example. These orange giants can grow to sizes that boggle the mind, often becoming the centerpiece of agricultural fairs and competitions. But how exactly do they get so big? Through selective breeding, we've coaxed out genes that promote massive growth. By choosing the largest and healthiest specimens to cross-pollinate, farmers and scientists have been able to enhance the traits that lead to gigantism. This process takes years of careful planning and observation, ensuring that each generation of pumpkins is bigger and better than the last. These giant pumpkins aren't just big, they're heavyweights, often tipping the scales at over a ton. Imagine the effort it takes to move one of these behemoths. Special equipment is often required just to transport them from the field to the competition. The secret lies in the pumpkin's vascular system, the network of vessels that transport water and nutrients. This intricate system is like the plant's lifeline, ensuring that every part of the pumpkin gets the sustenance it needs to grow. Giant pumpkins have an enhanced ability to move massive amounts of fluids and sugars throughout the fruit, fueling rapid cell expansion. This is akin to a supercharged engine in a car, allowing the pumpkin to grow at an accelerated rate. Think of it like a superhighway for plant food, allowing for extraordinary growth. The more efficient this system, the larger the pumpkin can become. It's a marvel of natural engineering. But even with ideal genetics and optimal growing conditions, there are limits. The environment plays a crucial role in the growth of these giants. Factors like soil quality, water availability, and temperature can all impact the final size of the pumpkin. Gravity starts to work against you. As the pumpkin grows larger, the sheer weight of the fruit can cause structural issues. The skin may start to crack, and the plant itself can struggle to support the massive load. The sheer weight of the fruit can put stress on the plant, making it susceptible to collapse. This is one of the biggest challenges in growing giant pumpkins, ensuring that the plant can support the fruit until it reaches its full potential. So, while nature can produce some impressive giants, we need to turn to engineering for truly colossal creations. Innovations in agricultural technology and genetic engineering hold the promise of even larger pumpkins in the future, pushing the boundaries of what we thought possible. When it comes to building giant food, we enter the realm of structural engineering and food science. It's no longer about coaxing a single plant to grow larger. Now, we're talking about assembling multiple components into a cohesive and, most importantly, edible structure. Imagine a 10-foot-tall burger, a culinary Mount Everest, begging to be devoured. But before we grab our oversized spatulas, let's consider the challenges. A burger this big isn't just about stacking more patties. It's about understanding how each element behaves under pressure, how to distribute weight, and how to prevent a catastrophic collapse. Let's break down the anatomy of our colossal burger. We have the foundational bun, the meaty core of patties, and of course the essential toppings. Each presents unique engineering hurdles. The bun, for instance, can't just be a giant bread boule. It needs internal supports, almost like scaffolding, to prevent it from collapsing under the weight of the patties and toppings. The patties themselves pose a challenge. Cooking such a massive amount of meat evenly is no mean feat. And then there's the structural integrity of the patty itself. Too much weight, and it could crumble like a sandcastle. Section 5. The breadth of the matter bun engineering. Building a bun to support a 10-foot burger is a feat worthy of architectural ingenuity. A traditional baking approach simply won't cut it. We're talking about reinforced dough, potentially baked in sections and then carefully assembled. Imagine a lattice structure, baked into the base of the bun, providing crucial support. The dough itself might be reinforced with edible fibers, increasing its tensile strength. This is where food science meets engineering. We need to create a bun that's not only strong but also delicious. The last thing we want is a burger that tastes like cardboard, no matter how impressive it looks. Patty predicament: keeping it together. The patty is the heart of any burger, but scaling it up presents a unique set of challenges. First, there's the cooking. When you increase the size of a patty, you also increase the complexity of ensuring it cooks evenly. The thicker the patty, the more difficult it becomes to achieve that perfect balance between a juicy interior and a well-seared exterior. Grilling a patty this thick would result in a burnt exterior and a raw interior. This is because the heat struggles to penetrate to the center of the patty without overcooking the outside. It's a common problem that many chefs face when attempting to create larger-than-life burgers. One solution could be to cook the patty in sections, ensuring even doneness throughout. By breaking down the cooking process into manageable parts, chefs can maintain control over the temperature and cooking time, resulting in a more evenly cooked patty. Another approach might involve slow roasting the meat, similar to how one would cook a whole hog. Slow roasting allows the heat to penetrate more evenly, reducing the risk of burning the exterior while leaving the interior undercooked. This method requires patience but can yield a perfectly cooked giant patty. But cooking is only half the battle. Once the patty is cooked, we need to ensure it holds together. The structural integrity of the patty is crucial, especially when dealing with such large sizes. We also need to consider the structural integrity of the patty itself. A giant patty can easily fall apart if not handled correctly. The weight and size make it prone to crumbling, which can be a disaster when trying to assemble the final burger. A giant, flat patty is prone to crumbling under its own weight. This is a significant issue because a burger that falls apart is not only difficult to eat but also loses its appeal. The challenge is to find a way to keep the patty intact while maintaining its deliciousness. One solution could be to create a layered patty, with each layer slightly smaller than the one below it, creating a more stable, pyramid-like structure. This method not only helps in maintaining the shape, but also ensures that each layer is cooked evenly, adding to the overall flavor and texture of the burger. We could even incorporate edible skewers, made from something like pretzel dough for added support. These skewers can help hold the layers together, providing the necessary stability without compromising the taste. Plus, they add an extra element of fun and creativity to the burger, making it a unique culinary experience. Toppings on top of toppings. The challenges of scale. The toppings. They are the crowning glory of any burger, the elements that add flavor, texture, and visual appeal. But when you're scaling up to a 10-foot burger, these toppings become more than just a garnish. They become a challenge of epic proportions, the crowning glory of any burger. Each topping must be carefully considered, not just for its taste, but for its ability to hold up under the weight and size of this enormous creation. But on a 10-foot scale, even something as simple as lettuce and tomato presents logistical nightmares. Imagine trying to lay a single giant lettuce leaf on a patty that size. It's not just about placing it, it's about ensuring it stays intact and doesn't wilt or tear. Imagine trying to lay a single giant lettuce leaf on a patty that size. The sheer size and weight of the leaf would likely cause it to tear under its own weight, making it impractical for such a large-scale burger. It would likely tear under its own weight. Instead, we might need to use smaller leaves, strategically placed to create the illusion of a single massive topping. This way, we can maintain the visual appeal without compromising the structural integrity. Instead, we might need to use smaller leaves, strategically placed to create the illusion of a single, massive topping. This method allows us to distribute the weight more evenly and avoid the pitfalls of using oversized, fragile leaves. Tomatoes could be sliced into thick wedges, providing structural support while still offering that juicy burst of flavor. Thick wedges can hold up better than thin slices, preventing them from becoming mushy and losing their appeal. Onion rings could be supersized, battered, and fried to a crispy perfection. These giant rings would not only add a delightful crunch, but also serve as a sturdy layer within the burger, helping to keep everything in place. The key is to think about each topping not just as a flavor component, but as an element that needs to withstand the structural demands of this colossal creation. Every ingredient must be chosen and prepared with care, ensuring that it contributes to the overall stability and deliciousness of the burger. This is the true challenge of scale. The future of food: giant possibilities and ethical bites. The quest for giant food is a testament to human ingenuity and our fascination with the extraordinary. As we delve deeper into the science of food and explore new culinary technologies, the possibilities are endless. Imagine three-dimensional printed steaks, crafted from plant-based proteins, or towering cakes assembled by robotic arms. The future of food is ripe with innovation, pushing the boundaries of what's possible. But with great size comes great responsibility. We need to consider the ethical implications of supersized food, the resources required to create these edible behemoths, the potential for food waste, and the message it sends about consumption and excess. It's a delicate balance, one that requires careful consideration as we navigate the exciting and potentially overwhelming world of giant food. Conclusion: food for thought. So how big can we go? The answer, as with most things in life, is, it depends. Nature has its limits, but human ingenuity knows no bounds. We can engineer our way around structural challenges, manipulate ingredients on a molecular level, and create culinary marvels that defy imagination. But as we reach for the culinary stars, let's not forget the simple pleasures of a perfectly cooked meal shared with good company. After all, the most important ingredient in any dish, no matter its size, is love. Now, if you'll excuse